Hey class, I hope everybody had a wonderful spring break. We're going to pick up where we left off in our lesson material in chapter 11. And the goal of today's lesson is to pick up again where we left off before we took a break from things when you guys were on vacation. So I am actually going to be reteaching over lesson 4, and my goal in this lesson is just to make sure that you guys have a proper understanding of what functions are, and I want to go through some illustrations, some examples with you guys to help you not only have a better understanding of what the term function means, but also how do we evaluate them. So let's go ahead and get started. So first of all, I just want to draw your attention to the definition we have here. So this is just a very basic definition. A function is a rule that evaluates every input with a corresponding output value. Now, we can think of function rules like a machine like this, or a blender. So we've got something going into this machine, we call this our input, and then the function does something to that input, some type of operation or operations, it could be more than one, and then it spits out an output. And so that's just a little illustration I wanted to give you guys describing the behavior of how functions work. Now, for the terms input and output, sometimes there's some other concepts that we need to be familiar with. First of all, the input is known as what we would call an independent variable in math. So independent variables means that they are not dependent on any other values or measurements at all. And the typical variable that we use in algebra for independent variables is the variable x. And then the output is known as our dependent variable, because the output depends on what we plug in to our function rules. And in algebra, we would typically use the variable y to indicate our dependent variable. So just make sure that if you do come across these terms, independent versus dependent, just remember independent is always associated with the input of your function, and dependent is always associated with the output of your function. So let's take a look at some examples that I have down below right here. So the first example I have to illustrate a function rule, let's suppose we plug something into our function. In this case, we'll plug in the variable x, and let's suppose the rule for our function is to add 7 to the input. Well, since we don't know what x is, then we can represent that as the algebraic expression x plus 7. So your function rule, if you were to write it out algebraically, would look like this: y equals x plus 7. So again, y is your dependent variable, it's the output, and the output is equal to x plus 7. Here's another example I have off here to the side. Let's suppose we take our input, and let's suppose the following rule is we multiply by 3 and then add 12 to our input. So we can represent our function rule by this expression: 3 times the input, or x plus 12. So the function rule would be written as y equals 3x plus 12. So let's take a look at some practice problems down below. So we've got these 4 questions, and for these examples, it says write function rules for the following statements. So the first one we have, number 1, the output is double the input. Well, so let's identify some things. Remember, output is y, input is x. Anytime you see the word is in math, it's always referring to equals to. So y equals double the input. Oh, 2 times x. So your function rule is y equals 2x. Let's try number 2 out. The output, y, is equal to the quotient of the input and 12. Well, let's think about what the word quotient means again. If you recall, the word quotient refers to an operation of, you guessed it, division. So it's the result of the input divided by 12. So our function rule would be y equals x divided by 12. Or another way that we can write this out is y equals x over 12. This is probably going to be the more formal way that we would write division expressions, so please keep that in mind. Now, you can pause the video right here and you can try these problems out on your own as quick check problems. So feel free to pause right here and try these out, and then whenever you're done, hit play and then compare your answers. So let's go ahead and work these out. So we have the output is the quantity of the sum of the input and 5. Now this sounds like a very complicated statement. So let's tackle this part first right here. The quantity of the sum of the input and 5. Well, sum means addition. And we have our input variable over here. So we're going to add x and 5 together. Now you'll notice we have this statement in front, the quantity of this. Anytime you see this phrase in math, the quantity of something, we're going to surround that expression with a grouping. So we're going to use the parenthesis operation. So the quantity of this raised to the 3rd power. Now, we need to make sure that we start off with y equals, because it says the output is this right here. So we would write it as y equals x plus 5 in parentheses raised to the 3rd power. Now number 4, the output is the input squared decreased by 8. So let's think about how we would interpret this. So the output y is equal to the input squared, so x squared, so that's a power of 2, decreased by 8. Decreased by 8 would be minus 8. So there are your answers for those quick check problems. So I hope that made sense, going through how do we properly write function rules out. Now, let's move on to the next topic, which is the main objective of the lesson today, which is evaluating function rules. Now, to evaluate a function rule, there are 2 important steps that you need to remember. The first step is to replace the input variable with a number. A lot of times you'll be given that number to plug into your function rule. And once you replace that input variable with your number, then you would simplify the expression using order of operations. So let's look at example 1 down below. It says evaluate the function rule y equals 4x minus 7 for x equals negative 2. So the proper way to show our work when we evaluate these function rules, we always start off writing the rule first. So y equals 4x minus 7. So we're going to replace our variable with the number that we're plugging in for the input, which is negative 2. So if you're going to show your work properly, we would write it like this. So remember, this means multiplication. 4x means 4 times x. So 4 times negative 2 minus 7. Now we need to make sure that we follow our order of operations correctly. So if you ever get stuck and you forget what to do, sometimes it helps to write the mnemonic PEMDAS out just to help you remember the order of operation process. Well, we don't have any groupings of expressions, so no big parenthesis groupings, no exponents, but we do have multiplication that comes first. So 4 times negative 2. So let's figure that out. 4 times negative 2 would give us negative 8. Then minus 7. Now we've got the last step, which is negative 8 minus 7. Or it's the same thing as keep, change, flip. So negative 8 plus negative 7, which gives you negative 15. So there would be your answer for this first example. Let's take a look at the next example down below. This one's a little bit more involved. It's got a few more operations with it, and we're going to use a decimal number to plug in for our variable x. So we're going to be using the value 0.25 to plug in. So I went ahead and did the first 2 steps for you, which was to write the function rule out first, and then showing where we are plugging in, replacing the input variable with our number given. So let's go ahead and work this out. Now, we're dealing with parentheses, so we're going to take care of the stuff inside of the parentheses first. So let's do that. We'll take care of the exponent later, but right now we need to simplify the stuff inside of the grouping. So the first thing we're going to do is multiply 8 and 0.25 together. Well, 8 times 0.25 would give you a value of 2. Then we got plus 4 off to the side. Now we can finish up simplifying inside of the parentheses. So 2 plus 4, you guessed it, gives you 6. Now, technically at this point, you don't need the parentheses anymore since we were evaluated down to a single digit or a single value. Now, we're going to evaluate the exponent, which is just 6 times 6 times 6. And so if you work this out, again, you can show it by hand, or if you have a calculator to speed things up, that'll make life a whole lot easier for you. So if we work this out, so 6 times 6 is 36, carry the 3. So that's going to be, I think, 21. So 216 would be the final answer for that evaluation problem. So now we've got some practice problems down below that we are going to attempt to try out. I'm going to do the first 2 examples for you just to get you started. So let's read the directions first. It says to evaluate. Let me make sure I've got this lined up correctly. There we go. So evaluate the following function rules for a equals 3 and b equals negative 4. So you'll notice I'm using 2 variables here for the following expressions. And technically I should have rewritten these as y equals for all these. So let me make that fix right quick. So y equals all these function rules right here. So that was a mistake on my part. So let's evaluate. So we're going to replace the variables a and b with our numbers 3 and negative 4. So 3 plus negative 4 would give you a y value of negative 1. So now let's try the next one out. So y equals 3 minus negative 4. Okay. So keep, change, flip would be y equals 3 plus positive 4. So 3 plus 4 gives you 7. So there's the first 2 examples. Now if you want to try the next ones out on your own, feel free to pause the video right here. And then when you're done working these out, hit play and compare your work. So let's go ahead and work through these problems. Starting with the first one. So y equals ab plus 6. So y equals, it's going to be 3 times negative 4 plus 6. So following order of operations, the first thing we're going to do is multiply. So negative 12 plus 6. Negative 12 plus 6 gives you negative 6. So there's your answer for number 3. Number 4, the next one. So let's replace our variables. Y equals, so a squared becomes 3 squared plus, see, b squared turns into negative 4 squared. So now, before we add these values together, we need to evaluate each one of these exponents. So 3 squared is the same thing as 3 times 3, not 3 times 2. That's a big error some students make. It's the repeated multiplication of the base number. So 3 times 3 would give you 9. Then this would be negative 4 times negative 4, which gives you 16. So 9 plus 16 gives you 25. So there's your answer for that one. Now the last two down below. Whoa. So b squared minus 4a. So that's negative 4 squared minus 4 times 3. So let's see, negative 4 times negative 4 gives us positive 16 minus 4 times 3, which is 12. 16 minus 12 gives you 4. All right, last problem, number 6. So let's replace our variable. So a plus 3 in the parentheses turns into 3 plus 3 squared over negative 4. Okay? So again, we got parentheses. Take care of that first. So 3 plus 3 is 6. So we have 6 squared over negative 4. Now remember, this means a division operation when we have the fraction bar, but before we divide, we need to take care of the exponent. 6 squared is the same thing as 6 times 6, which is 36 over negative 4. 36 divided by negative 4 gives you negative 9. So I hope you found those examples helpful. Let me know if you have any questions. I'll be glad to help you out. But that concludes our lesson on evaluating function rules. Thank you.